Now, unless you have been living under a rock for the last year or so, I'm pretty sure you will have heard of ChatGPT. So this is an AI chatbot, and we can use it in order to generate some interesting parametric equations. So if you haven't heard of it, I've left a link in the resources section. Just click on that link and it will allow you to open up this free version. And this is the free version that I have here. So let's say we want to generate some simple parametric equations. So you could ask it to, can you generate some simple parametric equations, and we want ones that kind of look nice whenever they're plotted off, which look cool and interesting. Okay, so it will go ahead and generate these for us, and of course each time you do it, it will generate some other curves. Now the ones that's generated here look actually quite complicated, so we'll just quickly have a look through. So what you could do is you could potentially pick out each of these individually and then have a little look online. So you just go into Google and you could type in, for example, Lissajous figures, and you can see what they look like. And if they look quite nice, then you could try and attempt to generate this parametric equation here and generate it on our CPU. So these all look quite complicated. So let's ask can you give me some basic simple examples? So hopefully we can get something a little bit easier. So here's ones that we've actually already seen. So we've already generated a circle and we have already generated a spiral. So let's see, can you give me some more simple ones, please? So straight away, there's two here that look really interesting to me. The ellipse, this would be a great one to generate because we don't have the ellipse generated so far. We could generate the ellipse using the Bresenham's algorithm and ellipse algorithm, but it's probably going to be quite complicated and a bit time consuming for us to work out how it all works. So a simpler way would be to generate it here parametrically. So a good exercise would be to take this parametric equation here and generate an ellipse. And you can see that it's very similar to the circle. The only difference is we've got a value of A and a value of B here. So we could take the circle parametric algorithm and just change it, and it literally would only take minutes, and we could be able to generate ellipses. Now here's another one, a cardioid. You could take this here, and I'm unsure of exactly what this is. So what you could do is you could take it and then just type it into Google and see what it looks like, see what the image is like. And if you like the image, then you could go ahead and try and to generate it. So that's another one you could test out. And here's another simple one here. So you could just continually ask, give me some more. And that's one that I do know. So here is the cycloid. So that would be an interesting one to generate. And again, if you put in the cycloid, kind of runs like the point on a wheel would run. So if the wheel was running round like this, the point in the wheel would run, the center of the wheel, the center of the point of the wheel would run like this. Okay, so that's the cycloid. And that's very useful because it's used If we turn it upside down, it would be the path of shortest time that a ball would roll in. Okay, so I've actually covered that in the Calculus of Variations course. Here's an asteroid as well. I think that's kind of shaped like this. Okay, and then there's the helix, so we could generate a helix. The helix would be different because we've actually got 3 parameters here, and we couldn't generate that here because we've only got access to 2 values for our parameters, our x and our y. But you could continually ask, and it will generate as many different parametric equations as you like, and just pick 1 or 2 simple ones. I would suggest the cycloid and the ellipse, and give it a go and see if you can code it in their assembly language and run it on our machine. So that's all for this video. Thank you for listening. I'll get you on the next video. Goodbye.